Welcome back to Ozarks Live. With us now is Dr. Theodor Jordan, chemistry teacher at Nixa High School. Welcome.
Pleasure to be here.
He's coming on to teach us a little bit about fireworks, the chemistry behind them, because it is fireworks season, right?
Yes, we only have 13 days till July 4th.
So we got to start making our own fireworks.
Well, probably won't go that far, but you know how fireworks work are very interesting because you're basically generating a variety of wavelengths of light based on either the excitement or the burning of chemicals. And so it's actually a very simple process where we just go ahead and heat up some chemicals here, turn on the gas here. Oops.
We brought in our Bunsen burner here.
Portable Bunsen burner, very useful.
Yes.
So we have some wooden sticks that have been soaked in water, so we don't burn the actual stick and generate wavelength that way. We're testing the actual chemical.
Okay, let's bring the lights down a little more if we can.
And so once you dip the little stick in the proper chemical, in this case this is strontium chloride, and the chemical gets excited and you get this nice reddish wavelength of light, which is one way of generating the nice light color.
Yeah.
So then we safely dispose of that, and that way the studio does not burn down. And so, you know, when you're firing off fireworks the 4th of July, you know, it's a very simple scientific process where you're conserving energy. The energy has to go somewhere, and it goes in the form of light. So there's some
that looks like
copper sulfate. And so you get the nice bluish green color, you know, in your fireworks, and everybody, you know, enjoys themselves while eating a burger or drinking or whatever it is they do.
But we don't realize there's actually chemistry behind
That's right, there's chemistry behind it.
And it's actually impressive how long that color is burning.
Yeah.
So in the fireworks set, are they stacking these things?
Yes.
Like, okay.
They're basically, you know, they have stacks of different chemicals in there, and they have a propellant which burns, you know, the rocket up anyway, and so they're generating heat and therefore exciting the electrons, you know, in the chemical. All right, so
electrons. Do you remember that term back from way when?
No,
the
I'm
electrons.
just kidding.
This is not red. This is sort of a light lavender color. This is potassium chloride. So you can get, you know, a whole spectrum of colors. This is a little fainter. Okay, and eventually the stick will burn, but we get rid of that.
Yeah, so are there any kind of like patterns, like different types of chemicals that will burn typically certain colors, or is it just?
So I didn't bring this in. The magnesium is like the nice bright white, but it's also very hazardous and tough to put out sometimes.
Yes.
And so you get strontium, magnesium, copper, zinc, and so on, and they all generate a spectrum of color. Even sodium chloride, you know, regular salt will burn a nice orange. So
I kind of forgot that will burn.
Something I keep thinking is like, what's something that would surprise someone at home about fireworks?
Well, the same principle that lights up fireworks lights up your LED lights, the modern LEDs or your phone screen. You know, you're exciting electrons and atoms, and the electrons do all the work. And so that's what we do. We're an information electron-based society. We excite electrons all the time, you know, and that's how we run our lives now. Whereas before, you know, it was shoveling coal. You know, so I think phones are much more exciting than shoveling
Every time you get your phone out, I'm going to be like, look at those electrons.
Honestly,
getting all excited.
I know. Just wiring up.
We kind of forget that science is applicable to what we actually see and what we do.
Exactly.
You know, we take it all for granted. Stay right there because we're going to come back and let you show us a little bit more, teach us a little bit more.
And hopefully don't we burn the studio down in the meantime.
Shut this off.